Okay, good afternoon, everybody. This is my second session of the day. How many people who are here right now were at the earlier session at 1:30? Oh, good. Okay, a good number of people. So for this session, I'm going to do a slightly different perspective, but it's really about the same issue, right? It's really about how do you keep some protection for your service and for your data. And at one end of that continuum, we have high availability, and at the other end of the continuum, we have disaster recovery. And we have many points along that continuum. So I'm going to talk for this session about what are some of the strategies or some of your options for handling these failures with disaster recovery solutions that we have. I'm also going to talk a little bit about the high availability solutions that we looked at very briefly in the previous session. So what do I want you to get out of this session? I want you to understand what you need to protect in exchange, and what are some of the different solutions and the features that we're providing for you to protect those things. And I want you to also understand about site resiliency. So there's been a growing interest in site resiliency for obvious reasons in the last several years. People are worried about losing whole data centers. And so we have taken our solutions for high availability and worked them so that they can be used for site resiliency and for whole data center failures. The high availability solutions really do reduce your chance of disaster, but where disasters occur and the disaster sort of outstrips your high availability solutions, we have those disaster recovery options or features to help you out. So our agenda is, there's a number of different ways that you can organize this information. And the way that I choose to organize this is to think about what are the failures that we're actually really worried about. And you can kind of group them. It's an arbitrary grouping, but you can group them into sort of the small scale failures, sort of the mid-sized car, and your large car, right? The large scale failures. Okay, I think a lot of people have probably seen a slide similar to this. This is to show you what is a typical configuration or deployment of Exchange. And where we have the hub and the CAS servers or the front-end servers, we're less concerned there about data protection. We're mostly there concerned about service protection. When you get to the mailbox server role, there you're concerned about both server protection and data protection. So what are your options? Well, for the server configuration, which is stored typically in the Active Directory, we would suggest that you do Active Directory backups, and that's what Active Directory recommends to you anyway. You can also go for the edge server. You can go and export that configuration into, so that then it's maintained for future use. If you lose your edge server, you can then go and re-import that configuration to get your edge server back to where it had been. The Exchange services, if we think of, there's the Edge, Hub, and CAS, we typically think of those, as I said, as load balancing or mostly concerned about the service. There's not a lot of state. In the hub, there are some queues, but that state is very transitory. It changes very, very quickly. The mailbox, because it's so stateful, because that is where your data is, your primary data, then we look at clustering for that. The end user data, as I just mentioned, there's the transport queues, but that's transitory. If you had a zero data loss requirement, if you were completely intolerant to any data loss, then we would say that you probably need to have a synchronous replication solution for that. For the mailbox and public folder database, that's going to be the focus of this presentation, where I'm going to talk about what are your disaster recovery options, or what are really your protection. Let's talk about your protection options for mailbox data and the mailbox server. Excuse me. So, as I said, I've broken these up into types of failures. So you have your small scale. That would be typically somebody deletes an item by accident, or you have just a single disk fail. You had an entire SAN, but just a disk failed, or you had one database get corrupted, or a single log get corrupted. In the mid-scale, I'm thinking there about an entire server. You lose a full server, you lose a whole cluster, you lose an entire SAN. Okay, there's a lot more potential to lose data. There's more potential for there to be a longer outage for your clients. And then the large-scale failure I think of as the full data center failure. So you've lost everything. And what are you going to do about that? Are you going to protect for that? And do you need to protect for that? So let's look back a little bit at 2003. In 2003, if we're going to start with the small scale failures, which are the single disk or single database, what were your options? You could use the 7-day default dumpster for getting back an individual item that had been deleted accidentally, or you could restore from backup after that 7-day period. If you wanted to do a single mailbox recovery, there was a 30-day default retention there, and after those 30 days, you would restore from backup. You could kind of think of backup and restore in this world, in the 2003 world, as kind of the solution for everything. It was really for all kinds of the small scale failures, the lost items, the corruption. And while you were doing backup and restore, you could provide service with no data with a dial tone. So what are some of the improvements that we've made in 2007 around for the small scale failures and that protection? Well, we have some VSS improvements, the VSS being for the backup and restore. You can now do VSS backups in parallel. So before it was that you had to do one storage group at a time, and now you can do multiple storage groups at the same time. For the restores, you can now restore a backup into an RSG when it's a VSS backup. And you can also restore to a variety of locations. So before you had to restore back to the spot where it had originally been. Now you can restore to a different server or to just a different location. And you can then use some of some tricks that we have for rehoming, which some people in this room who were at the previous session would know about. We also, for VSS, we know that there are people who would go and do their backup and restore. They would go to restore, and they would find, after they had spent all this time restoring, that it wasn't going to work. There was some kind of error there. And a lot of time was wasted. So we're now doing a lot of upfront error detection to ensure that your restore is going to succeed before you actually start the restore. We also allow you, with the VSS backups, to restore a number of different different backup sets. And then you can go and say, at this point, I'm ready to go ahead and do the replay on it. So for example, if you have, say, a full backup from 2 weeks ago, and you have a number of incremental backups with the logs, you can go and say, I'm going to restore that full, and I'm going to go and restore the logs. And once I know I've got the last set of logs, now I can say, now go and do the replay. Finally, we also allow you to do the logs only restore if you've done a full backup or a copy backup. So say, for example, you want to take the full from a week ago, and you don't want to take the database from your full from this week, but you just want to take the logs. Then you can do that with 2007. We also now have a consistency check API. So this is primarily useful for companies who provide the backup solutions. And this API they can use to check the consistency of their backups. Have a lot of people understood that we are de-emphasizing the streaming backup? Is that news to everyone? How many people have heard about this de-emphasizing? Okay. How many people are happy about that? How many people are unhappy about that? Okay, so it doesn't seem like it matters one way or the other. A couple of people here and there. We're really stressing now the VSS backups. In the update rollup number 3, we had for backup and restore, we had some fixes and some changes. The rollups 4 and later really didn't have anything in them that were relevant to backup and restore or for HA or DR, so I didn't put that information down here. But you can see we had an issue with backups, the abort backup hanging, that's been fixed. And there's a number of things here. I don't really want to spend a lot of time going into them, but when this deck is available, you can read through it. I think they're fairly obvious. And definitely check out the KB. We also are allowing you to do the simultaneous backup and a restore. So what that means is if you are doing a backup for one storage group, you can now do a restore for a different storage group. And the fact that you can do parallel backups means you can have, say you're doing 5 or 10 or 20 backups, you can do a restore at the same time on a different storage group. These are the changes. The VSS, VS Writer support, that is there for the parallel restores. The remote streaming backups, we're blocking those by default. And that's mainly around the remote aspect of that. The other change we've made is that in the database headers, we've got the copy and differential now, those backup times represented in the header. Okay, so those types of backups, the copy and the differential backup types, were not originally represented in the header, and now they are in the database header. Some other improvements for the small-scale failures. We have a disaster recovery wizard that's primarily for the RSG. So it will go and walk you through the different steps in order to restore the extraction of the database, the analysis of the database and the logs. And the wizard is really primarily focused on the RSG. We have provided dial tone for alternate servers. So in 2003, if you wanted to provide dial tone service, which is just the service without any data, you had to do it on the same server that the database had originally, or the user had originally been on. Well, what if that server is not available? What if the whole entire server has failed? You want to be able to give them dial tone, but you can't. So now, in 2007, you can provide that service at dial tone on another server while you're building out or rebuilding out the failed server. In order to do this, you would use the move mailbox configuration only. So that is rehoming the user in the AD. It's updating the AD with the new location of their dial tone mailbox. When you use move mailbox configuration only, the auto discover feature in 2007 will automatically update their profile. So they don't need to manually go in and change their profile to the new location. Finally, we have, for these small scale failures, we have also extended the default of the dumpster, of the information store dumpster, the deleted item dumpster, to 14 days. So now for items or for restores that were typically performed because a person accidentally deleted an email, now you can use the longer retention to retrieve those emails. And this is this value, the 14 that is configurable. You can also do a single mailbox restore. I know that there have been people who have asked for that. It's still using the RSG for that, the recovery storage group for that. You would go and restore the database into the RSG, and then you would use this command, the restore mailbox, in order to extract that. You can get more information about it at the KB article that's listed here. You're able to do the filter and the merge of database of mailbox data with restore mailbox. So say, for example, you wanted to extract out of this database and out of this mailbox just specific mail in a given time frame, or specific mail just around different criteria. You can do that with the restore mailbox command, which is a PowerShell command. We've also made some of these commands around the RSG and backup and restore scriptable with PowerShell. So you can see the comparable command, PowerShell command, that you would use for these different operations that you would perform. Database portability. How many people have heard about database portability? Okay, good number, still quite a few who haven't. Database portability is the idea that a database typically lives in the AD under a specific server, and it's tied to that server. And if you were going to, say, for example, restore a database, you'd have to restore it to the same server. That database can't really be moved to a different place. Well, now with database portability, this is what enables you to restore to a different server. It allows you to put your data on a different place, your mailbox, your databases, your storage groups in a different place, and then use move storage group path and move database path and move mailbox configuration only to now rehome all that information about the database. The database becomes essentially unlinked from the server. And again, in this case, when you go and use database portability to move your databases around, you will get the automatic updates of the profile with auto discover. Now, how you move that data, there are a variety of ways that you can move that data. You can do file copies, you can do the backup and restores, and we talked about SCR in the previous session, where we used this to actually activate an individual database on a standalone SCR or standby continuous replication target. So what are some of the new approaches in 2007 around continuous replication for small-scale failures? So the small-scale failures, remember I was saying it's disk failures, it's database corruption. Well, you're trying to get your data redundancy, right? How do you get that? Well, typically you got that through backups. But you can also get that through continuous replication. And if you have one server, you have a fairly small organization, you can use LCR, local continuous replication, to get another copy of your data. And it just provides the data redundancy. It doesn't provide any of the server redundancy. And you have to make sure when you use this that this server is able to handle the load of both client load as well as the replication load that's happening between the two storage devices. And then there's the cluster continuous replication, which is providing both the data and the server redundancy. So when you use backup and restore and your server dies, then what do? If that's a server that you just have to toss out, you get a new server, or you can clean that server. You now are going to do setup, and you're going to do setup recover server. Well, if you use cluster continuous replication, you've got that server right there, and you don't experience the outage that you would experience in trying to rebuild a server from scratch and trying to also get your data back from your database, from your backups. So what are some of the new backup and restore options with continuous replication? We had this question in the earlier session this afternoon. You can take backups from your active or your passive. The backups from your active can be either the legacy streaming, or they can be the VSS from using the information store writer. With the passive, you can take your VSS backups from there, but you have to restore to the active. You cannot restore to a passive. And backups from the passive are just with VSS. There's no support for streaming. With the VSS, with the way that we do this with the active and the passive is that even though it's the same writer, and it's essentially the same writer ID, we distinguish by having a different instance name. And we also, the two have different path names. So you can see here on the slide that for the passive, we have the replica in that path name, which distinguishes it from the active. In 2008, Windows 2008, you should be aware that NT backup is really being de-emphasized. So it's not really being provided as a utility to do your backups. It is a utility that's used to restore earlier backups that were done in Windows 2003. If you want to take backups and you're using Windows 2008, you need to use the new Windows server backup utility. It is based on VSS. So it's not a streaming backup utility the way NT Backup was. We do have support for this writer in the Windows small business, in the SBS server. We expect that for businesses that are small, they're going to be getting SBS anyway, so that's where they'll find the support for this utility. For businesses that are larger, then our recommendation is that they would use something like DPM and some of the partner products that are out there for doing backup and restore. We've also added some protection for the data both in terms of ensuring that the data is good, is in good shape, as well as ensuring that the data is actually gone or scrubbed when you go to delete it. So in SP1, we've added this checksumming, online maintenance checksumming, and it happens on the active. It is an opt-in, so you have to choose to use it. And it is going to use some portion of your maintenance window. It's going to use about a half of that. So you need to be aware when you go and are calculating what your maintenance window is going to be and how much time you have. And also when you're figuring out how big your databases are, you're going to want to be aware that the checksumming is going to take about half of that time. And if it does during that checksumming come across any errors, those do get the 1018s, for example, they do end up going into the event log. And most of those are also handled as alerts in MOM and will come up in the Microsoft Operations Manager and will come out as alerts as well. The page zeroing is really about really knowing that some data is deleted. So when you go to delete something, typically it just gets marked for deletion and then gets deleted kind of at the right time when it's most convenient for the system to do it. With the page zeroing, this will go through and actually clean out and zero out any of those pages so that there is no way that data can ever be seen again. It is performed during DB scan, and it's quite performant. It's about 8,000 pages, excuse me, that end up in a 1 megabyte log. So when it's going through and actually logging that it scrubbed those, it really doesn't take up a lot of space. You can see the second bullet. I'll just call this out actually a little more carefully. For the page zeroing, it's performing that on the active, and the way it gets to the passive copy of the data is through the replication system. So it's going to go copy the logs that represent the zeroing, and then it's going to go and play that into the copy database and zero out in the copy as well. Okay, standby continuous replication. We talked about this in the other session. I'm just going to go through it relatively quickly here. But the idea is that you can have a target for replication that is outside of a cluster or is a target from a standalone. Okay, it can be a CCR cluster or an SCC cluster, a clustered continuous replication cluster or a single copy cluster. It allows you to do replication one-to-many or many-to-one. So the idea here is that you can say, I want to have several copies of the data. I don't want just one copy, I want 2 or 3. So you can take one database, one storage group, and you can replicate it to 2 or 3 other servers. Similarly, if you had multiple sources, you had multiple servers, and you only wanted to replicate several specific different databases, you didn't care about some databases, you cared about other databases, you could go and select them from many different servers and have a target machine that is specifically there for the purpose of your recovery of the replication of having the data protection. And as I mentioned in the other session, standby continuous replication is not a clustered solution. It doesn't do automatic failover. It is a manual activation. So backups with SCR. So as I said, thank you. As I said, SCR is a target for replication that is outside of the cluster. It can be from a standalone to a standalone or from a cluster to a standalone. Now, what happens when you do your backups in this environment? We don't support backups from SCR specifically. You could go, if you wanted to, you could go and suspend the replication and copy off the files. It's going to be just, file level backup copy that's completely controlled by you, but you won't get any of the features or benefits that come with the backup, the backup tools. We think of the SCR copy as essentially a backup in itself. We think of it as typically a third copy that you would usually want to have local redundancy in your local data center, and then in a secondary data center, have this as a third copy. So you're going to potentially want to do backups from your target. And the way that the truncation works there is we ask a number of questions. We're going to truncate only if it's been backed up, the database has been backed up, and the log file is below the checkpoint, so we know that that the data has actually been written out to the disk. And does the CCR or the LCR copy agree that it should be deleted, it should be truncated? What that really means is, has that log made it over to the other side, over to the copy? And only at that point will we truncate. Yes, we will. We'll also make sure that has it been inspected. If it's been inspected, and the inspection is make sure that that log is in good shape, that it doesn't have any corruption in the log. And if it passes the inspection, then we will go and truncate. Now, on the SCR target, we're going to also check, is it below the checkpoint? And in SCR, we have two settings that delay when you go and delete your logs, and also when you go and play those logs into the copy of your database. So the replay lag time is the amount of time that you want to hold on to your logs before you actually play them into the database. It allows the database to be sort of a point in time behind. And this can be useful when you're trying to prevent or protect yourself against database corruption. If you know that the corruption potentially is getting introduced from a log because of logical corruption, you can lag it behind and only play up your logs to that point of the corruption. The truncation lag time essentially says, well, I'm going to go and replay those logs into the database, but I also don't want to truncate my logs for a certain amount of time. I want to hold on to them a little bit longer than I hold on to them and in a certain sense, it becomes a little bit like a backup and restore, a backup there, because you are holding on to these logs a little bit longer than you are for the source. Now, if those are true, then yes, we will go and truncate. So what are some of the benefits around continuous replication? The main thing here, in terms of failures and disasters, you're going to minimize your outages. In the database corruption case, you're going to actually, if it's a physical corruption, that's not going to get replicated. Unlike in a backup and restore, you are likely going to go and you may end up going and copying into your backup, copying that corruption. We also protect against the log corruption, as I said, by having the replay lag. And for the storage failures, it's also minimizing the outage because we have a quick failover. So in terms of a recovery and protection, the continuous replication gives you the fast recovery, okay, but you also have to have the additional hardware for that. Your backups and your backup and restore, your dial tone, your database portability are still very, very valuable in the case where you don't need to have or you don't want to have the extra hardware for SCR or any of the other clustering services. Okay, what are some of the mid-scale failures? Well, as I mentioned, I think of those as the server failures. Now that can be a standalone server or that can be an entire cluster. Well, in 2003, what did you do? If you lost a server, you went and you had to rebuild that server and you had to set up DR, right? Which was essentially to go and take that server and take the information from the AD and reassociate that server with the information in the AD. There were standby clusters in 2003, and if you had a full cluster failure, you could use a standby cluster. That took quite a lot more work to go and activate and get that standby cluster into a spot where you could actually use it. Or if you didn't have a standby cluster, you would have to go and rebuild it. For large storage failures, like an entire SAN failure, your DR approach was to go and have backup and restore, and you could use dial tone for temporary service. The HA approach to that would have been using synchronous replication from a third party. Now, I know that a lot of people believe that SANs don't fail, or that SANs are good protection, and they can be really good protection, but they also can fail, and they can be a single point of failure. So you need to be, and when they do fail, it's pretty catastrophic when they do fail. It may not happen often, but when it does happen, it can be very, very difficult to recover from. So what are some of the limitations for those 2003 solutions? Well, backup and restore can incur long outages, and they also can be error prone. As I mentioned, we do a consistency, or we do a check to ensure that the backup is, the restore is going to be successful. But what if it's not going to be successful? You don't have any data. You don't have any protection. In 2003, dial tone to provide some service, even if you didn't have the data, the dial tone had to be on the same server. So it was really no help to you if you lost the entire server. And the setup DR switch was only for standalone. So if you lost a standalone server, you could go and rebuild it out and set up a DR for that standalone server. But you didn't have that option when you lost a cluster. You could do a sort of complicated set of operations to get the cluster rebuilt out, but it was not something inherently easy. So what are some of the improvements? Well, as I mentioned earlier, for the small scale failures, even for the server failure, the full server failure, we would recommend that you could use dial tone if you are doing backup and restores and you know you have to do a restore for that entire server. We would recommend that you do dial tone on an alternate server that you know is operational at that time. That at least provides your users with service, with email service. They can send and receive email during the time that you're trying to rebuild out your original server. As I said, the setup recover server or setup DR in 2003 still exists today, but now we also have setup recover CMS, which is recover clustered mailbox server. And that makes recovering a full cluster much easier to do than in 2003. Some of the other enhancements are around the things I talked about around VSS restores for full storage, SAN failures, and for full server failures. With the VSS, we now support the RSG, restoring to an RSG, restoring to alternate paths, restoring also from different sets, from different backup sets. Database portability is also very useful for the case where you've got a server failure or a full SAN failure. You can go, if you have operational servers somewhere, you have operational clusters, you can go and go in and get the data. If you can get access to the data, you can go and put that data on an available server and then use the database portability to rehome the users. And at least in this case, the users will have their data available to them. It's sort of the flip or the opposite of the dial tone. Here they get their data, they're going to have service, but they're not on their original server until that's built out again. And again, for server and SAN failures, CCR, cluster continuous replication, can be really useful in that it does provide the server and the data redundancy for protection of both your service and your data. So the new approach in 2007 SP1 is around SCR. So it is manual activation, as I mentioned, and the enable storage group copy is how you go and configure an SCR target to be a target of replication for a given storage group. You can also use SCC as your source, and you can get extra protection for your SCC cluster with SCR. So one of the things that, I'm the high availability lead PM, one of the things that really kind of drives me crazy about SCC is that there's a very big single point of failure there, which is the storage, right? The data is sitting in one spot. And if you wanted to have a second copy of that, you had to use a third-party replication solution. Now you can use SCR as a replication solution, and you can have it replicated to a standalone, or actually to another passive node of another cluster. The one issue with this configuration or this topology is that you still only have protection that is, if you have them stretched apart, if you have your main SCC cluster in one data center, for example, and you're targeted another data center, you don't have any local redundancy for that data. With SCR as your target, what you get with SCC for the full server is if you lose your entire cluster, right? Again, remember, I'm talking about full server failures, for full cluster server failures. You now have the protection for that full cluster by going and targeting an SCR server. So this provides you both the local protection for your service and data as well as the remote protection if you have a CCR as your source for your SCR. The one issue left here is that if you just go and target a standalone, for example, you are not going to have any server redundancy after you activate that. So in order to get full redundancy, full protection for your data and for your servers, you could essentially have as your target a passive node and have a second node, passive node in there, in this cluster, in a standby data center, And then when you go to activate it, it becomes, for example, a CCR server, or it becomes an SCC server. So now you have kind of the best of all worlds in that case. For the big one, the big total site failure, the data center's gone. Somebody tore up the power cable that went to the building, or there were power outages from storms, or there was an earthquake, something that takes down your entire data center. What did you do in 2003? Well, you had to either rebuild or restore your servers and all your clusters of all the roles in your data center. That could be weeks of work, right? You could use standby clusters for it. You would have to go through the steps in the operations to make that standby cluster operational. You could have geographically dispersed clusters, which is Windows 2003 has a lot of information about how to go and configure these geographically dispersed clusters. But it's, again, there's some issues that you have to be aware of that I'll get into in a moment. If you wanted to have your data in another data center, in a standby data center, you had to use a third-party synchronous replication. And finally, again, there was always backup and restore that you could use to try and recover. But try and recover an entire data center's worth of data, that would be very, very hard work. So what are some of these limitations? Well, I think I've talked about most of them. The restores can be time-consuming and really impractical for large sites. The backup and restore, I've mentioned some of the issues there with it being time-consuming, and you can get a significant amount of data loss from that. And with the standby clusters, they didn't provide data redundancy without the third-party replication. Also, there were mostly synchronous replication solutions from third parties that were supported, but and the asynchronous replication solutions typically were not supported by Microsoft. Some of that's changing a little bit depending on the solution. However, with the synchronous replication, while we support that, those solutions, there is an issue with the latency that can be due to those solutions, particularly if they're not very performant. Now, some of the solutions have become more performant and they're less of an issue today than they were in the past. The limitations of the geographically dispersed, again, I think I mentioned that for the total site failure, they don't have any of the data redundancy. There's also a complication around the quorum. Where do you put the quorum for this dispersed or this stretched cluster? If you put it in the data center that's your primary data center, then it fails. Now you don't have quorum, right? If you put it in the secondary data center, then you also have the issue of, say you, for example, lose connectivity between the two data centers. The other thing was that the nodes had to be on the same subnet, which was an issue that we have heard loud and clear from customers in and around CCR. And another big issue was that all of the hardware had to be on the WCL, on the Windows catalog. So you were restricted to what they actually allowed and supported. So new approaches for site disasters. CCR can help protect you against a full site failure, a full data center failure. You can go ahead and stretch that stretch that CCR cluster. CCR cluster is exactly 2 nodes. You put one of your nodes, your active node in your primary, and your passive node in your secondary data center. They each have their own Storage, so you know you're getting your data redundancy there as well. You can get your hardware from wherever. It doesn't have to be from any specific catalog. You have the file share witness, which is what's used for quorum in this case. So the quorum with file share witness is very, very easy to activate. So if you have it in the primary data center and your primary data center fails, going and configuring that on the secondary data center as simple as making a file share. It's very simple. What you have to have in this particular configuration or deployment, when you're using CCR with Windows 2003, they do have to be on the same subnet. They cannot be on two different subnets. And you have to make sure that your pipe between your two data centers is going to be big enough to handle a lot of different types of traffic. Okay, it needs to be able to handle both the replication data. If you end up failing over to that passive node, it has to be able to handle the client traffic as well and any heartbeating. So I have right here some animation that will show you how this will work when you stretch it with 2003. So you can see you've got the primary data center and the secondary data center. We have our public and our private networks. They have to be the same subnet. When you fail over, you now see that your active is in the secondary data center. What we suggest is that you actually make this, well, actually you have to make it 180 site because it is the same subnet, okay? So the red box here outlines the AD site. When there's that failover, now any of the client traffic and the hub traffic is going to go across that pipe, the network pipe. So here you can see what the network load needs to be. You need to take into consideration all of these factors, the replication, the hub and CAS traffic, heartbeats, AD accesses, AD replication, and so on. You're probably going to consider whether you want to have full redundancy in your secondary AD site, your secondary data center, and if you're going to want to have all the other server roles there. Now, if you make that a second AD site that's separate, it can be performing its own service. You have to make that decision. Is it going to be a dedicated site or is it going to be non-dedicated? Is it going to be providing service regardless of whether there's any kind of primary data center failure, or is it going to be there specifically for the case when the primary data center fails? Now, say that primary data center does fail, then you need to make the decision to go ahead and activate it. We're not going to do any kind of automatic failover for you because if something so catastrophic has happened, we usually want a person there to make that decision to activate the secondary data site. So you're going to move over your MX records. Now you're going to go and pull the CAS and the hub servers into the AD site that was represented by the data center that failed. In this case, it's the Redmond AD site. You're going to move your file share witness over. So this is what gives you the quorum, okay? Gives you the quorum for the cluster. And you're going to move over the CMS over to the passive node. And now once the DNS replication has occurred, clients will be able to will be able to connect through. This is just showing that you're going to want to bring up your hub and CAS servers, and here the client can connect. Now, when the primary data center comes back up, need to be very careful about the order in which things come back up. You decide you're going to go back. You want to make sure your networks are up. You want to bring up your DCs, bring up your hub servers, bring up your CAS servers, and move the CMS back over to the primary data center, the CMS being the clustered mailbox server. Move your file share witness, again your quorum, back over to the primary. Make sure your edge servers are up. Move your MX record over. And once the DNS update has replicated, clients will be able to connect. Now, back in your standby data center, you need to reverse. You're going to take the CAS and hubs down, and you're going to bring those back into your Quincy or your standby AD site. Okay. So with SP1, we have the different types of replication. We have here, this is to show you that with CCR, with Windows 2008, we have the multiple subnets. You don't need to, at that point, you don't need to necessarily worry about the issues with having that stretched subnet. There are people who have been concerned about the network issues of trying to stretch the subnet. With 2008, you don't need to do that. If you wanted to continue to have a stretched cluster here, then you can, but you don't want to ever activate that second copy, then you can go and run cluster pause, and that will allow the replication to continue, but you will never automatically fail over to that passive node. With standby continuous replication, we have the local standalone to a remote standalone. So in this diagram here, you can see you have pretty much a full mirror image of all of the server roles, and you're now copying over, replicating data across from your first data center to your second data center. You can also have a local CCR, which would give you the local redundancy to an SCR target remotely for your site resiliency. Now you've got 3 copies of the data. You also can use the public network. I mentioned this in a previous session. You can use a public network, or you can use the mixed network for your replication and for your seeding. So with SCR, you have a lot of different options for the configuration when you have to, well, you do either way, but in this case, talking specifically about data centers, you can see here you have 2 data centers. You have the, in this case, you have 1 Active Directory logical site. And you have the CCR target, 2 CCR sources and 1 SCR target. You can also have SCR or SEC as your source and SCR as your target. You can have 1-to-1 or 1-to-many. Again, this is representing across 2 different data centers. And you can have your local SEC be many-to-1, where you have multiple SEC sources to 1 SCR target. So to configure this for site resiliency, what would you do? Well, you need to enable the storage group copy on the standby machine. The standby machine represents the SCR target. If you find that it's not seeding, you can go and do an update storage group copy to force the seed. But typically, it will seed automatically with enable storage group copy. And then you want to turn on, make sure you have test replication health on to monitor the health of the replication. When you want to switch over to the standby cluster, you're going to run restore to force all the logs over to the copy, and then you're going to run setup recover CMS on your target. Now this isn't the case where you're assuming that your target is a passive node for potentially a CMS cluster. And then when you need to go back the other direction, you then would go and clear out what had been the source but had failed. You're going to make it a target. You're going to bring it up to date. You're going to clear it of any cluster configuration information it had, and then you're going to run setup recover CMS there and make that again the primary. So this here shows you essentially what that might look like. You can see with SCR, you have the network load. It only involves here now the replication and the AD replication. You don't have to worry about all of the other kinds of traffic, particularly any of the clustering traffic that was a concern. Okay, I have a demo for this. I want to make sure, do I have enough time to do the demo? Hello back there? Well, I'm going to go for it. And make sure I can. Okay. This is not coming up. Hello back there. My demo machine is not coming up on the. What's that? I wonder if it's that one. Yes, please. Mm-hmm. Actually, can you go up to the microphone so other people can hear? And anybody else who has questions, please go up to the microphone and I'm happy to answer them.
Yeah, in reference to the scenario where you mentioned that you have a single copy cluster, and you're replicating over to a standby, but this passive node is a member of another cluster. And you stress the fact that it has to be passive.
Yes.
Now, if it's functioning as a cluster on the other end, and which means that, let's say, it suddenly received the role of being an active part in that cluster, what happens to that configuration?
Okay, I didn't catch the last part. If something happens to the cluster from the target, that's the source?
No, if the SCC
Yep.
is replicating to a SCR.
Right. If something happens to the SCC cluster?
Yeah, well, regardless of.
Okay.
Back again to the scenario where you have a single copy cluster,
Yep.
and you're replicating using the standby solution over to a passive member of another cluster.
Yep.
Okay? Now, since it's another cluster, something might happen on the other end that might suddenly decide that this passive node is an active node.
No, it will never become an active node because it's not exchange aware at this point.
Okay.
It really isn't.
So when you mentioned,
it's really a Windows. You can think of it as really a Windows cluster at that point.
yes, so that's what I'm thinking. So when you mentioned the passive node, you're just relating it to the cluster function. To the exchange function.
So when it's a passive node in the sense that you have installed Windows clustering on there, okay? Yeah. It's got the exchange bits there, but when you run setup recover CMS, that is when it will now become an exchange server. It's not an exchange server until that point.
Thanks.
Okay. All right. So I have. Can everybody see that back there? Okay. Thank you. So what I have here is I've got a. Let's see if I can. I have a CMS called Kumquat, and it has a mailbox database here. We have this is a CCR cluster. We have the data, as you can see here. All these logs are, this is the active node in the CCR cluster. This here is the passive node in the CCR cluster. Now remember, the CCR cluster is your source, okay? Now, if you look here, okay, we have some logs, but this is really not up to date. This is this is going to be my target, okay? If I go and I run storage group, kumquat. Oops. What did I do? Oops. Sorry. Okay, you can see it's empty. There are no standby machines here. So now what I'm going to do is I'm going to enable, actually, I'm going to enable storage group copy kumquat SG3, this is demo SG, and I'm going to standby machine node 1 site 2. This is in a different AD site, okay? Now it's enabled it. I need to take you over to here, okay? So now we have get storage group copy and kumquat MOSG. Did I type that right? Oh, sorry. Storage group. Is that spelled right? Okay. I'm going to run the enable over here. It might actually, the issue with this is that I ran it, and this is a really good point. I ran it in the other AD site. I didn't run it in the AD site that is where the target is sitting. So the best thing is actually to make sure that you run it into the AD site where your target lives, in the case where this is really a site resiliency solution, okay? Where they're local, it doesn't really matter, but where it is remote, they're remote from each other, you want to, because otherwise you have the AD replication issue. So storage group copy, kumquat, you get to see how well I type. Standby machine, and this is 312 node 1 site 2. Okay, now if we look at, right now we look and see what it looks like in the AD, then, and if I do get storage group copy status for kumquat demo SG on the standby machine, you can see, all right, it says it's not configured. This is because it goes and does a check from the AD just at every so often. It's not, I think it's like every 5 or 10 minutes or something like that. So in order for me to get that to reflect in the AD right away, I would do a net stop exchange REPL. And now I'll start it up again. This is the replication service. And now if I do this, it shows that it's healthy. okay? So now I'm going to be getting more logs over here. And you can see that I have a lot more logs than I had before. Now these are two separate AD sites, okay? So you can see I have quite a lot more data over here. Now if I go and access, so Isla Cole is my compatriot on this, and she let me use her name. How many people know Isla? A lot of people probably do. Oh, okay, not too many in this room. Okay, and that's me. Okay. So now I have my data here, okay? I have access to my database. Now say I go and I go ahead and kill this, this machine here, all right? So going to shut you down. Actually, I want to shut down the passive too. I don't think I have that open, so let me get to the passive. Is that coming? Did that come up? Okay, I'm going to get to the passive. I'm going to shut that down first so that I don't have a failover node 2, site 1. I'm going to close down the passive node, and then I'm going to close down the active node. So I don't have any cluster. Now there was a session in San Francisco several weeks ago. I don't know if anybody heard about it, where they actually took a sledgehammer to the machine. And well, actually, I think they first pulled out some things, and then they did a sledgehammer, and really, it was quite a performance. And people were kind of jaw-dropping when they saw the sledgehammer come. Okay, so now I'm going to shut down the active node. Okay. So I should have, if I go and I look here, I should not have any, well, when it actually decides to close down. Has it closed down yet? It's closing network connection, so it's probably going to keep. All right, so. Yeah, okay, it's dead. All right, it can't do anything. So now what I want to do over here is I want to run restore storage group copy on this standby cluster and this standby continuous replication target. I want to let me make sure I get this all right. Kumquat demo SG standby machine 312 node 1 site 2, and I'm going to force. Now this is going to pull over any logs that it's able to get to. It's also essentially going to say this guy is no longer a standby target. And it's going to go through, and the force, if you try to do it without the force, it's not going to work. The force is because it can't communicate with the active node. Okay, so it's going to tell you here that there's potentially lost data in this case, all right? Now what I'm going to do is I'm going to do recover, set up recover CMS. CMS name, kumquat, which was my CMS. I'm going to do CMS IP address 10.1. These are IP addresses that I got ahead of time. Oops. Okay, so now it's taking this server, and it's saying this server and that CMS within the AD, we want to connect them. We want what's in the AD to represent now this server, which was your standby target, okay? And this standby target was a passive node for a Windows cluster. And when you finish the setup, what you then do is you go and you mount the database, okay? You go into the Exchange Management Console, you mount the database, and there are a couple of things that you can try. If it turns out that your database won't mount, you might have to run ESCUtil on there /mh on it on the database. And that should typically, why did it fail? Okay. Amazing. This is the, okay, what is it saying? Okay, reboot from a previous installation is pending. So, okay, one of the things that I didn't talk about in the previous, in this session, but I talked about it in the previous session, is that when you go and you want to go and activate your standby, your standby target, you need to make sure that you have run a reboot anytime you do an upgrade. Okay, so the reason this has happened to me is because just before my previous session, there was an automatic update on my machines. And so the automatic update, it needed to do a reboot. This is essentially saying that it can't go ahead and do the setup because it hadn't really completed the setup or the update from before. So what you would do here is you would have to go, I'm not going to do it because it's going to take too much time, but what you'd have to do is go back, go and do a reboot of your machine, try and do this again. It would go through, you would end up having the setup work. You would then go and you'd be able to mount your databases. And then you would go, and if you went back to your OWA, you would be able to connect, and you would see that all of the mail was there, that the client was able to connect to these mailboxes, to these databases sitting in the standby target. Okay, so this is not going back to my other slides. So the main thing, so the main thing that I want you to come away with is that there are a lot of different options, solutions for your different types of failures, your small scale, your medium scale, and your large scale. Now that's obviously not the way that you need to think about it. You can think about it other ways. But I've found it helpful to think about the small ones, how do I want to deal with those? The middle-sized failures, how do I want to deal with those? What are my options? What can I do? Do I want to just use backup and restore? Does that work for my company? Does that work for my team? Is it sufficient? Do I need to have a higher SLA? If I need a higher SLA, then what are my other options? Can I use, for example, can I go ahead and and use some of the database portability, the dial tone on alternate servers. So then you know that your users will have access to their data while you're trying to get your service back on the original servers. And if you have an even higher SLA, if you really can't afford any kind of outage time or downtime, you need to achieve some number of nines, 99.99% uptime, then you probably want to consider looking at some of the continuous replication and the clustering features that would allow you to get those better SLAs. So tomorrow I have a session, an interactive session, and I'll be talking about a number of these issues and answering questions and having much more one-on-one. I don't know if I have time to take any questions. Can I get from the back, can you let me know if I can take some questions now, or is time up? No? Okay, I'm going to be here. I'll go outside, and if anybody has questions, I'm willing to hang out there and answer them.